Good day everyone, and especially to my professor Sir Arman, and good day also to my fellow student. I'm here in front of you to discuss about or talk about the permutation and combination. So let's start about with combination. Combination. Combination is a mathematical technique that determines the number of possible arrangements in a collection of items where the order of the selection does not matter. And in combination, you can select the item in any order. Take note that the formula for this combination is n factorial and over r factorial close parenthesis n minus r factorial. So this is the formula that I'm going to use in the combination. The n is the total elements in a set, and the r is the number of selected object. The order of the object is not important. And the last thing is that this one is which is the factorial. So after I introduce you the combination, I'm going to give you some example of combination. I have three example of combination. The number one is number of winning the lottery and selecting the children to be a member of a class. And last one is the picking three finalists. Now I'm moving on to the example. I've already write the example so that I don't have a dead time. If we wish to buy a milkshake and may choose any three flavor from apple, banana, cherry, and durian. The combination banana, apple, and cherry. So if we want to create a flavor combination from these probable flavors, let us first abbreviate the names of the fruits by picking the first letter of their names. A is for apple, B is for banana, C is for cherry, and D is for the durian. For the question that I've shown you earlier, there are only potential answer we can produce, which are the ABC, apple, banana, cherry, ABD, apple, banana, durian, ACD, which is apple, cherry, durian, and lastly is the BCD, which is the banana, cherry, and durian. Also, keep in mind that this is the only feasible combination. So, moving on, let's go in the next topic, which is the permutation. Permutation. When the order of arrangement counts, a permutation is a mathematical approach that specifies the number of alternative arrangement in a collection. A common mathematics problem involves selecting only a few items from a group of an object in a specific sequence. And take note, the formula of the combination is n factorial over close parenthesis n minus r. This is the formula for the permutation, which I said earlier. The n is the total number of elements in a set, and the r is the selected elements arranged in a specific order. And lastly is the factorial. So moving on, I have also a example for the permutation, which is the sequence of the number of a lock selecting individuals for team by position, picking first, second, and third place. As you can see, the examples that I've given is they're all in order. And for the combination, the order doesn't matter. Oh, so I have also a example for this topic. A license plate begins with 3 letters if the possible numbers are A, B, C, D, E, and E. How many different permutations of these letters can be made if no letters is used more than once? In this problem, I'm going to solve it by using the formula earlier that I've mentioned. So, the formula earlier is n factorial over r and n minus r factorial. The question is, the problem is involved by 5 things, which is A, B, C, D, and E. So I'm going to put the 5 here, the 5 factorial. Next is the close parenthesis, which is n, which is 5, and the r is 3 because it's only taking a 3 at a time. So I'm going to put a 3 in here and a close parenthesis. So I'm going to solve this. I'm going to put the 5 factorial again. So 5 minus 3 equals 2 factorial. So next is I'm going to show the 5 factorial, which is 5 times 4 times 3 times 2 over 2 factorial, and lastly is the equal, which is I'm going to solve it here. I have my calculator. Is 5 factorial over 2 factorial is equal to 16. So this is the answer for the example problem for the permutation. Now I'm going to tell you about something, or say, give you examples, some problem that can be used in our daily lives or real life problems. So now, combination problem. Combination problem. Out of a group of 5 people, a pair needs to be formed. The number of possible combination can be calculated as follows. So we can see the 5 people. So I'm going to apply the formula for the combination, which is n, which is n factorial over r factorial plus n close parenthesis is n minus r factorial. That is the formula for the combination. Now I'm going to solve now the problem that I mentioned earlier, which is the n is the 5 over r, which is 2 factorial. Next is the open close parenthesis and 5 minus 2 factorial. So this is not the n. We're going to make it simplify. So 5 factorial again, and 2 factorial, and the 5 minus 2, which is 3. Let's put a multiplication sign. Now we're going to solve this by using again my calculator. The 5 factorial is equal to 120. Next is 2 factorial times 3 factorial. 2 factorial times 3 factorial, it is equal to 12. So I'm just going to make it simple. 120. So, and 2 times 6, which is 12, right? So equal 120 over 2 times 6, 12. Okay, going to divide it. So the answer will be 10. So there 10 possible combination can be calculated as the problem earlier. So next one is the permutation. This can be long because my problem is a bit long. So I'm just going to make it faster. Imagine you are a partner in a private equity firm. You want to invest $5 million in two projects. Instead of equal allocation, you decided to invest $3 million in the most promising project and $2 million in the less promising project. Your analysts shortlisted 6 projects for potential investment. How many possible arrangements are available for your investment decision? This example is a permutation problem since the allocation of the money for the two projects is not equal, which is the selection order matters in this problem. So, for example, consider the following arrangement. Invest a $3 million in a project for project A, and the $2 million is the project B. So, it's not equal because 3 and 2 is not equal. The options are not equal, therefore, we must use the formula above to determine the number of available arrangements. So, the formula for permutation is n factorial n factorial over open close parenthesis n factorial n minus r, then let's read factorial. So based on the question earlier, there are 6 projects that the analyst that mentioned earlier. So the n is 6 factorial, and the n again is the 6 minus 2, and the 2 is the 2 project which is project A and B factorial, and we're going to solve it. 6 factorial and 6 minus 2 is 4 factorial. So the answer is 6 factorial and over 4 factorial is equal to 30 possible combination. Therefore, you can get 30 possible investment arrangement based on the 6 projects shortlisted by your analyst. So, for my conclusion, use of the permutation and combination. A permutation is used for the list of data where the order of the data matters, and the combination is used for a group of data where the order of data doesn't matter. So that's it. That is my topic for this video. I hope you learned something from my topic, which is combination and permutation. Thank you for listening.